Hello! Now we're going to talk through experiment 2.3, which is diffusion and molecular size. And I'm helping, and Fiona is here again to help me. So the first thing we need to do is we're going to set up an experiment in a beaker with this dialysis tubing, which is made of cellulose, and it has a pore size of a fixed size. So it's very different from a living cells membrane because living cells, remember, are selectively permeable and will actively choose and control what can enter and leave the cell. In the case of dialysis tubing, what can move through the pores are substances smaller than the pore size. So today we're going to compare three solutions. We're going to compare iodine, starch and glucose and see which, if any, can move through the pores of the dialysis tubing. So the first thing we will need is a beaker of water, which we have here. We'll add some Lugol's iodine to that. Fiona, would you like to do that?
I would like to do that.
We'll add a dropper full of Lugol's iodine to the beaker of water. We'll get a nice bright yellow colour.
I'll just add
maybe another
more.
one.
We want this to be nice amber, like you see here.
Okay, so we have our dialysis tubing, and what we need to do now is put a knot in one end. We've wet this dialysis tubing for ease of use. We're going to tie a knot just like you would tie in the end of a balloon to seal off that dialysis tubing. I'm having trouble with my gloves here. Okay, I've made a nice tight knot in one end. Remember, if we don't seal the ends of the bag, substances will be able to leak in and out of the tubing through the ends, not just through the pore size. So we need to make sure that the ends are sealed properly, and otherwise your experimental results might be affected. So you can see the dialysis tubing. We can open it here, and what we're going to do inside the dialysis tubing is add 4 ml of a starch solution and 4 ml of a glucose solution. So that will go inside the bag. Let's do that now. The pipetter is set to 4 ml. Remember, I press to the first stopping point with my tip in the solution and lift my thumb slowly to suck up 4 ml of starch. So I'm now going to pipette that into the bag. Now I'm going to pipette 4 ml of glucose into the bag. So inside the bag will be a mixture of starch and glucose. Now we need to seal the other end of the bag. What we want to do, of course, is squeeze out the excess air. We need to leave some room in the dialysis tubing bag so that if any substance does diffuse into the bag, there's actually room for it to move in. If we tie a knot very close to the top of the liquid, there'll be no space for any other substances to diffuse into the bag, if they in fact can, depending on their size. So let's leave a bit of space, and we can either tie a second knot, and I think I might because we have room to tie a knot, so I'll just do that. And you can see I've squeezed out the excess air. I have some room there for any other solutions to diffuse in, and I have another tight knot at the other end of my bag. So we have inside the bag, remember, a mixture of starch and glucose. In the beaker, remember, we have water and iodine. So we'll rinse our dialysis tubing bag first using this weigh boat to catch the excess water, because just in case there's any of the solution on the outside of the bag.
So have a think about what iodine is going to be reacting with, why we use iodine in our beaker mixture when we have glucose and starch in our dialysis tubing.
Okay, so remember in practical 3, when we looked at the macromolecules, we looked at starch and iodine and when they combined, the colour change that we obtained. So let's put our dialysis tubing into our iodine water mixture, and we'll leave that for 30 minutes. And we'll come back after 30 minutes and we'll look at the results. So if we see a change in colour, perhaps something has moved. Let's have a look at that.
And we actually have one here that we prepared earlier. And lo and behold, we have seen a color change. So we can see, what can we see about the beaker fluid?
So the beaker solution is still yellow. Remember, it contained water and Lugal's iodine. If starch, which was inside the bag, moved out, would you expect to see a colour change? Have a think about that.
But what is different, and we can actually probably just grab our original
Absolutely.
one as well. What is different is the actual bag contents. Okay, we started with a clear mixture of glucose and starch, but now we have this blue-black mixture. So what must have happened for this mixture to have turned blue-black?
Remember, iodine is in the beaker and starch was inside the bag.
So the next part of this experiment is we want to actually be testing for reducing sugars, so glucose in this case. So what do you think, Susan? Should we find glucose in this bag solution?
Well, did we put glucose in the bag originally? Yes. So, of course, glucose is colourless, so we can't see a colour change if glucose has moved, and that's why we need to do the Benedict's test.
Yeah.
We have the beaker solution, we have the bag solution.
So we have 3 test tubes here. They're just small test tubes. We've labelled them beaker, bag, and water. So we're going to put about 2 mils of each solution. So we're using our water as a control. Okay, we should see a negative reaction when we react it with Benedict's solution. So there's 2 mils of our water in there. Now you see Susan opened the dialysis tubing just with scissors. We can grab 2 mils out from there. Okay, into our bag solution. And then another fresh pipette, and we'll grab 2 mils of our beaker solution. So you want to be thinking about the size of glucose and iodine and starch and trying to make some predictions as to whether or not glucose might have diffused across that dialysis tubing. We're going to put in a dropper full of Benedict's solution, okay? A full dropper, just so that we can see if there's a reaction, because remember Benedict's has a range of reactions, but if there's no reaction, it should stay this nice blue color. Now for Benedict's, we need to actually heat this solution for the reaction to take place. So Susan's gonna pop it in the water bath, and that reaction, it only takes a couple of minutes, and we should be able to grab those back in a moment and see which of those tubes have reacted with the Benedict's solution.